We start off with our second class on the chapter limits and derivatives. Now, before we move into today's topic, let me just start off with few problems from the previous topic. Now, the first one, evaluate limit x tends to 0 x by root over of 1 plus x minus 1. Now, whenever you see a radical sign, be it in the numerator, be it in the denominator, my job will be always to rationalize it. So let me rationalize. So upon rationalizing, I get x into root over of 1 plus x plus 1 in the numerator, and in the denominator I get 1 plus x minus 1. So 1 and 1 gets cancelled, x and x gets cancelled, and I am left with root over of 1 plus x plus 1, and here I can directly put the value of x, that is 0, and after putting, the value comes out to be 2. So this is our answer. Let me take another problem, a similar problem of this type. Evaluate limit x tends to 1 root over of 3 plus x minus root over of 5 minus x by x square minus 1. So again, let me do the rationalization, multiplying by its conjugate, by its rational conjugate, both at the numerator and the denominator. So after doing so, this is what I get, and I also break x square minus 1. So after breaking it, it looks like a room full of expression, but you can see that things will boil down a little bit. Now x minus 1 is there in both in the numerator and denominator. We cancel them out. After cancelling them, we are left with this. Now here I can see it is safe to put the value of x, so let me just put the value and calculate, and I get my answer as 1 by 4. Now let me just move to the topic. Now the first topic is algebra of limits, which we need to know, and the second one is some standard limits. These are the limits which we can directly make use of without proving them or without knowing how it is solved or how it comes rather. So now in algebra of limits, let us consider that limit x tends to a fx is L and limit x tends to a gx be M. Then limit x tends to a fx plus gx or fx minus gx is basically limit x tends to a fx plus minus limit x tends to a gx. So what does this mean? It means that the addition and limit, they are interchangeable. So you can so it is basically finding limit of addition is same as adding the limits. So limits and addition or subtraction operation, they are interchangeable. Similarly, limit of a product is same as product of the limits. So you can always interchange limit as well as product. Similarly, you can do so for quotient as well, but you have to ensure that the limit in the denominator must not give a value 0. So that has to be ensured. Other than that, it is fine. And also, limit of a constant time any function is basically constant into the limit. So the constant comes outside the limit. Now in all these cases, you have to see one thing, that it is limit x tends to a, here also limit x tends to a. So your limits has to be at the same point. So that has to be ensured. So limits on two different points, they can't follow this algebra. But if they are at the same point, then only it can follow this particular algebra. Next, standard limits. The first one, limit x tends to x to the power n minus a to the power n by x minus a is equals to n into a to the power n minus 1. Now how it comes, we are just skipping that part because already the syllabus has been reduced. We need not really know how it is coming, and anyway this is going to be discussed elaborately in class 12. So we just need to know that this happens. So we are not really talking about how it comes. So Number 2 is limit x tends to 0 sin x by x, that is 1. Limit x tends to 0 tan x by x is 1. Limit x tends to 0 1 minus cos x by x is 0. Limit x tends to 0 e to the power x minus 1 by x is 1. Limit x tends to 0 e to the power x minus 1 by x is log a, provided a is greater than 0. So this particular formula is applicable only for all those a's which are positive, not negative a's, because log a will be undefined in that case. And finally, limit x tends to 0 log of 1 plus x by x is 1. So these are the few standard limits which we are going to make use of in our problems. So let us take up few problems and solve, then we will understand how we need to apply them. The first one, limit x tends to 2x to the power 8 minus 256 by x to x minus 2. So this is basically in the form, if I can just write one more step, that is limit x tends to 2 x to the power 8 minus 2 to the power 8 by x minus 2. So this is basically in this particular form. So therefore this is in the standard form, x to the power n minus a to the power n by x minus 2, x minus a. So therefore the solution is n into a to the power n minus 1. So let me just directly put it. So it becomes 8 into 2 to the power 8 minus 1. So 2 to the power 8 minus 1 is 2 to the power 7. That is 128, and 128 into 8 gives you 1024. Fine. Next, number 2. Limit x tends to 4 x to the power 3 by 2 minus 8 by x minus 4. Now 8 can be written as 4 to the power 3 by 2. 4 to the power 3 by 2 is basically 8. So therefore it is again in the form x to the power n minus a to the power n by x minus a. So therefore it becomes n into a to the power n minus 1. Let me write it here somewhere, n into a to the power n minus 1. So therefore if I put the value, so n is 3 by 2, a is 4, so it is 3 by 2 into 4 to the power 3 by 2 minus 1. So therefore this is exactly what it comes, 3 by 2 into 4 to the power 3 by 2 minus 1. Now the value is, if you just calculate, the value is 3. Fine. Number 3, limit x tends to 0 sin 2x by x. Now I know the standard limit is sin x by x. So limit x tends to 0 sin x by x, this is equals to 1. Now that means whatever is here, it has to be here as well, then only it will become 1. So now here you can see I have 2x in the numerator but no 2x in the denominator. So therefore to bring that 2x, what I need to do, I need to multiply by a 2 both in the numerator and denominator. So therefore after multiplying, this is what I get. 2 is a constant, it stays outside the limit. Now limit x tends to 0 sin 2x by 2x, that can be written as 1, but there is one step inside which I have just not written, that is, rather from here you should consider 2x as y. So as x tends to 0, y also tends to 0. So therefore our limit changes into the limit changes into 2 limit y tends to 0 sin y by y. So basically I have skipped this step because it is pretty much understood, but at the beginning, as you are solving new problems, it is good that you write these steps. If you write these steps, it will become clear to you actually. Now, so your answer is 2 into 1, that is 2. Fine. Number 4. cot x minus cosec x by x. So for the first time we start off with trigonometric limits. Now obviously my standard limits are in sine, cos and tan, so therefore all our limits concerning trigonometry has to be converted first either into sine, cos or tan, in whichever form it is possible, and then we have to find our answer. So let me just do it. So if I simplify it down in the form of sine and cos, so cot is cos by sine, cosec is 1 by sine, so just after simplification it becomes cos x minus 1 by x into sine x. Now cos x minus 1 by submultiple formula, it can be written as minus 2 sine square x by 2, and sine x can be written as 2 sine x by 2 into cos x by 2. Just remember your trigonometry submultiple angle formulas. If you have forgotten, again I have the link here. Click the I button to remember or to just check out all those formulas which you have. Now let us come back. So I can see 2 and 2 gets cancelled, sine and sine will get cancelled, so I will be left with this minus of limit x tends to 0 tan x by 2 by x. Now once again the same idea, whatever I have in the numerator, that same thing must be there in the denominator. So for that I need to multiply by a half, both in the numerator as well as in the denominator. So after doing so, limit x tends to 0 tan x by 2 by x by 2, that is 1. So your final answer is minus half. Clear? Now let us move to number 5. Number 5, limit x tends to 0 sine 2x plus 3x by 2x plus tan 3x. Now this is a problem where we will see application of algebra of limits as well. So the first job is to divide the numerator and denominator by x. So if I do so, I get this sine 2x by x plus 3 by 2 in 2 plus tan 3x by x. Now division, I know that in case of division I can interchange the limit, as well as for addition also I can interchange the limit. So let me do so. So what I have done is I have taken limit inside the division. So basically what I have done, I have just done this particular thing. The thing was given limit of f by g, that is fx by gx, and instead I am writing limit of fx by limit of gx. So that I can do given that both the limits exist and the limit at the denominator is not 0. So now sine 2x by x, we solved this problem previously, so both the numerator and denominator must be same, so I need to multiply by a 2, and same in the denominator I need to multiply by a 3. So sine 2x by 2x, that is 1, tan 3x by 3x, that is also 1. So therefore you are left with 2 plus 3 by 2 plus 3, that is 5 by 5, and the answer is 1. Next, root 2 minus root over of 1 plus cos x by sine square x. So as I told you, the same idea, so let me just multiply by its conjugate both at the numerator and denominator. I have to rationalize it. So upon multiplication I get this, so 2 minus 1 minus cos x, so that becomes 1 minus cos x, and sine square x can be written as 1 minus cos square x. So this is what we have. Now 1 minus cos x and 1 minus cos square x I can cancel out, so I will be left with 1 plus cos x. Fine. Root 2 plus 1 root over of 1 plus cos x, that is there already. Or you can do one thing, you can just leave this outside the limit by putting the value and calculation. But anyway, so now let me just put all the values. So if I put x equals to 0, cos 0 is 1, and so therefore 1 plus 1 it is 2, and here I have root 2 plus root 2, that is 2 root 2. So therefore your final answer is 1 by 4 root 2. So basically most of the calculation is simple. It's just that you have to either find a factor which is required to be cancelled from both numerator and denominator, or if it is a trigonometric one, in that case try to match up the numerator and denominator with the same number so that it becomes 1. Number 7, 1 plus cos cube x by sine square x. Here I can write the denominator sine square x as 1 minus cos square x. Fine. So now 1 plus cos cube x, that is in the form of a cube plus b cube, can be written as a plus b into a square minus ab plus b square. We know this formula. So therefore both numerator and denominator factorized will look something like this. Now 1 plus cos x is the common factor, I can cancel it out. So after cancelling it out, I am left with this 1 minus cos x plus cos square x by 1 minus cos x. So now let me put the value of x. Now at x equals to pi, cos pi is minus 1. If you just remember, cos pi is minus 1. So after putting it, so it becomes 1 plus 1 plus 1, that is 3. And in the denominator it is 1 plus 1, that is 2. So therefore your answer is 3 by 2. And finally the last problem, problem number 8. 3 to the power x minus 1 by root over of 2 plus x minus root 2. Let me rationalize it once again. So after rationalizing, if I rationalize the whole thing out, I get something like this. 3 to the power x minus 1 into root over of 2 plus, it should be plus. It should be plus. Now root over of 2 plus x plus root 2. In the next step I have written it correct actually. In this step I just forgot. Now see one thing, this part, this particular part I can separate out, and the other part I can separate out. They are product of two functions, so I can separate out in two different limits. So this is what I have done. This is plus, please ensure. I am just writing it at every single step so that you don't mistake this. Now 3 to the power x minus 1 by x, this particular limit, this is a standard limit. If you remember, limit x tends to 0, a to the power x minus 1 by x, that is equals to log a, if a is greater than 0. So 3 is obviously greater than 0, so this holds. So therefore this limit will end up becoming log of 3. And in the other one, I can directly put the value of x equals to 0. So root 2 plus root 2 becomes 2 root 2. So therefore your answer is 2 root 2 log 3. Fine. So that is it. These is how you make use of the standard limits and the algebra of limits. Give yourself a try. And as always, if you have problem, please get it rectified. Thank you.